Some of my more popular videos have been about making cones of one sort or another. I've used cones in many of my projects, and I've found some sources for different styles. I discovered some ballisters for handrails that have tapered sections. These are fairly inexpensive, and several styles are available. They're made from mild steel, about 1/16 of an inch thick, and it's easy to cut out any section you may need. For larger cones, there's a company called Cone Engineering that has quite a few sizes in 16 to 20 gauge steel and stainless. These are often used for exhaust systems on cars and motorcycles. I have no affiliation with this company, but I've used their products and they have a lot to offer. My friend Mike Cooper needed some cones for his sculptures in sizes that weren't available, so he decided to make his own. He let me borrow the fixture he made so I could show you the process. Here's the cone rolling fixture that Mike built. It's a pretty beefy structure, but it has to be strong because it takes a lot of force to make sheet metal take on the contours of a cone this size. The top part of this can be moved up and down. There are nuts that you'll see that will pull this down so it's tight against the cone. But basically this top structure is what holds the sheet metal tight against the cone beneath it. And you can see there's a series of rollers. The reason there's so many rollers is because if there was one small diameter roller, it would actually flex in the center. So there are many supports that hold it in line, and there are small rollers that go between each support. I'm going to pull this top part off so you can see what's beneath it. So this cone is the business end of the machine. This has been turned from solid aluminum to be just the size of the inside of the cone we want to form. And there are tapped holes in this that can be used to secure a flat piece of metal to this arbor. Then when the flat metal is in place, this portion goes back to exert pressure to pull it down tight against the cone. And then you'll see that I will tighten these nuts to pull it down to start the curving of the sheet metal. So the first step for this is to make a pattern that we need to make the cone. So I'll drape a piece of paper over this form to make the pattern. So here's the pattern I've made by wrapping a piece of paper around the cone and trimming it so the edges just meet. So I'll use this pattern to trim a piece of 16 gauge steel that we'll use to make the cone from. I have a piece of sheet metal cut from the pattern, and we'll start putting this together. So I put a couple of holes in the sheet metal that align with some holes that were put into the fixture. That will align this piece of metal as we do the forming. So I'll get those screws snugged up. Now I can assemble the top part of the fixture. I've got nuts that will tighten down on both sides. I'm going to bring these all the way down. Okay, that's down pretty snug. So now the piece of metal between these side rollers has been pulled down pretty tight against the mandrel underneath them. And I'm going to actually tack weld the sheet metal to some steel pieces, and that's what's going to take the torque for rolling this. I don't trust these two small screws to transmit the torque into the part we're going to form into the cone. I was so eager to use the fixture that I missed an important step. The fixture will do a great job of rolling the bend in the center, but there's always a flat left at the edge. Here's a still from my heavy metal cones video that shows the issue. To counteract that, I'll use a bending brake to put a slight curl on both edges of this panel before rolling. I did some tests, and I found that if I make 5 bends spaced 3/8 of an inch apart, and each bend is 8 degrees, it will closely approximate the curve at the big end of the cone. All the bend lines need to converge at the same point, and a little math showed me the front bend line should be 75 thousandths apart. So I'll get this panel put into the brake. I'm sliding it up so that these lines are engaged with the front edge of the top jaw. I'll double check everything. Looks good. And I have a stop set on my brake so it can only bend to 8 degrees. So I'll push the lever until it hits that stop. We're there. Now we're ready for the second bend. So we'll line up on the second mark, clamp it, double check everything. Looks good. I'll bend it to the stop. Ready for the next bend. I'll double check everything. Looks good. And this will be our last bend. Okay, that looks really good. So I'll do the same bending on the other side. Now I'm ready to get this positioned and tack weld it to the mandrel. So the mandrel itself is aluminum, and I can't weld steel to aluminum, but there's an axle in the front made of steel, so I can tack weld to that. And I put a tab in the back that will allow me to connect the sheet metal to the mandrel. Okay, ready for the tack welding. I need to pull these screws out because they'll interfere with the rollers on the side of the fixture. Now I'll put the top of the fixture into place. Get the nuts tightened on top. Okay, that looks good. So this is my first time to use this fixture, so I don't know what kind of torque it's going to take to rotate it. But we'll find out right now. Mike welded a socket onto the end of this shaft. Okay. Well, it's moving. Looks really good so far. We'll go around the other way now. Looks pretty good. I'm going to make one more swing around in both directions. Okay, I think that's about it. So there's still a gap in here. I'll have to use clamps to pull this together to allow me to tack weld these edges. I used hose clamps to pull the sheet metal up tight against the form, and after it was tightened, I went over this edge with a hammer just to tap it down until it touched the form to complete the curl. And it's fitting the form very, very well, better than I expected, honestly. But there's a couple of issues we should talk about. One is there's a gap here that's too large to fill. It's about 3/16 of an inch wide on the big end and about 3/32 on the small end. So I'm going to revise my pattern so the sheet metal will be cut so I'll get a nice butt fit the next go around. Also, I realized that I put more bends in this than was necessary. I put 5 bends in this edge, and I think 3 would do. So if I do this again, I'll try 3 bends, and that should work. So this gap is too large to weld, so what I'm going to do is to pull this off the fixture, retighten the clamps to close the gap, and then weld and finish this joint. So I need to cut through these tack welds to get this off the fixture. Okay, now I'll use a hammer to tap this off. And now I can work on the bench to close this gap, weld it, and finish it. So I'll tighten all the clamps now to close the gap. I'll tap this with a hammer to get the best alignment I can. And now I can tack weld it. And now I can pull the clamps off. So the fit up is excellent, and now I can finish weld this. So the seam is completely welded. I need to plug the 2 holes on the back side, then I can sand everything smooth. And now we'll do the long seam on the other side. So the cone is finished, and I'm thrilled with how well it came out. It really has a beautiful smooth surface, and it's hard to tell where the seam is on this. So a big thank you to Mike Cooper for letting me borrow the beautiful fixture he made. One thing I might mention, Mike made the mandrel from aluminum. I believe he could make a mandrel from hardwood, and it should work just about as well. So I hope you all learned something from this video, and I'll see you next time. I love making these videos, and I'm honored that you're watching. Please like, subscribe, and click the bell to be notified about new videos. I read every comment, and I do my best to answer all questions. If you like what I'm doing, please click the Patreon link and become one of the great people who help me create new videos.